Good morning, everyone. So, as in our previous class, we have discussed about different aspects of introduction of DSP, that is digital signal processing. Now, try to start our next class, that is introduction to signal. So, basically, whenever we come across that of the concept of introduction of signal, first knowledge is that what is signal? A signal is basically defined as a function of time representing a physical variable. As clear, that means a voltage, a current that can be represented as a function of time is can be represented as a signal, or it can be either be defined as a signal is defined as a function of one or more independent variables. That means signal can be defined with respect to the function of time as well as for other independent variable also, that can also be defined as a signal. And third one, another most beautiful definition of signal is there. A signal is defined as a physical quantity that varies with respect to some independent variable, and that independent variable can be defined as a time, can be defined as a space, or one or more number of independent variables. So basic logic is that signal is defined as a function, a quantity that is a physical quantity, a physical function that carries some information, as well as it represents with respect to some, it defined with respect to some independent variables, and that independent variable can be time, space, or any other thing. Okay, now whenever we come across that of the definition of signal, now in our mind it should be defined that what are the different types of signal depending upon the knowledge of time, as signal is defined with respect to time. Basically, whenever we are defining that signal is basically defined as a physical quantity that varies with respect to some independent variable, but for most in maximum cases signal will be defined with respect to time, that carries information with respect to time. X-axis will be a time axis. So certainly with respect to the nature of time, signal can be defined as a two type of signal. There are two types of signals are there with respect to time concept. First one is a continuous time signal. Second one is a discrete time signal. First one is continuous time signal. Continuous time signal means where the time is being continuous with nature. And second one is time is discretized in nature. How they are clearly defined? The first one is continuous time signal. The signal that has a value for all point in time of function of time. That means for each and every instant of time, the time is present. The signal has a particular value, has each and every for time. That means for each and every portion of time, that each and every value of time, signal has some existence. In that way, signal can be defined as a continuous time signal. Continuous time signal normally be defined as a t, small t. It will be represented by t, and the signal normally defined by x of t or y of t in that way. T basically continuous time signal. So commonly, a continuous time signal can be expressed as example as human speech, because it is continuously up down up down up down, continuously we are getting the amplitude of that of the signal, and the graphical representation of that continuous signal will be defined by using this graph in that way simply. That means for each and every instant of time, every instant of time is present. From it is, let us suppose the time span is from -5 to +5. From -5 to +5, each and every second, each and every microsecond, each and every nanosecond is being present, and for that particular instant of time, we are getting the amplitude, particular amplitude of that of the signal, and that defines the overall concept of that of the continuous time signal. So after the completion of continuous time signal, let us try to get the knowledge of some discrete time signals. The time is discrete in nature. What is the definition for that discrete time signal? The signal that has a value for only specific point in time. That is, for each and every point of time, the signal is not defined. Signal is defined, signal has some existence, signal has some value for only specific points of time, typically formed by, and if I want to draw, if I want to make, if I want to form a discrete time signal, how to make? By taking the values of original function at a specific instant of time. Suppose in that way, if I want to show the graph, the graphical representation of that discrete time signal will be this, like this one. That means here it is being seen that the signal is being represented with respect to time. Here the time is defined by n. So signal will be normally defined by x of n. Discrete time means small n, it is being represented as. So whenever I am writing x of n, that is discrete time representation. When I am writing x of t, that is continuous time representation. So discrete time means x of n or y of n. Here it is being seen that for each and every value of n, signal is not varied. Signal is present, signal has some value for only 10 values of time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For only these values of time, the signal has some existence. For other values, suppose 0.5, 2.9, 3.7, 4, 5.01. For this instant of time, signal don't have any type of existence. That means signal is varying, signal has some value for some specific instant of time that is being defined in that graph. What is the example of this discrete time signal? Basically MP3 signal, a wave file. Basically this type of plot is basically discrete plot of a signal and is called as a stem plot. Stem means for each and every instant of time I am putting some pulse. An impulse signal can also be defined as that one. So in that way, we can define a continuous time signal and that can be discrete time signal. With respect to the concept of time, signal can be defined in that two way. The next one, a clearly comparison between the continuous time signal and discrete time signal we have defined earlier. What is that concept? First graph, there are 4 graphs are there. In both ways, they're continuous as well as discrete. In the first graph, it is defined as a continuous time signal. Second graph is also defined by a continuous time signal. But these two signals are both a continuous time signal, but with respect to the amplitude values, it will be continuous. First one is continuous in nature, second one is discrete in nature. The first graph is for each and every instant of time, whether it is time or it is for amplitude, both are continuous in nature. And the second way, that is also continuous time signal, but it is discrete amplitude, discrete value. The value is discrete as nature. That means we are not getting each and every value of that amplitude of the signal. We are getting this a finite number of levels are there for that of the amplitude. But for first one, the number of levels for that of the amplitude will be a continuous nature. That is, infinite number of levels are there for the amplitude range. So first two figures, the top two figures are defined by a continuous time signal and they are differed by its value with respect to continuous as well as with respect to discrete. The last two figures, that is the figure number 3 and 4, the bottom two one, both are defined as a discrete time signal. But in that both way, time is discrete in both the ways, but amplitude is first for the first picture in the last one, it will be a continuous values. And the second one, it will be a discrete values. The continuous values means the values of that amplitude of the signal will be defined in a continuous number of levels. Suppose the maximum level of the amplitude is 5 volt and minimum level of the amplitude is -3 volt. So overall 8 volt is there in that of the range of the peak to peak amplitude. So that 8 volt range can be divided into infinite number of levels are there, levels. So that is defined by continuous values of the signal. But if it is defined by, distinguished by or segregated by finite number of levels, that will be defined by a discrete valued signal. So continuous time signal can further be defined in two ways: continuous time continuous value signal and continuous time discrete value signal. In the same way, with respect to the amplitude values, discrete time signal can also be defined in two ways in the bottom two: discrete time but continuous value signal, discrete time discrete value signal. So in that way, the continuous time signal and discrete time signal can be elaborately defined in 4 ways. So in that way, we can conclude our second lecture. Is there any question about that question? Continuous time signal and discrete time signal? Okay. Thank you. Thank you, class.